Hello, how are you? Today is our important topic, sedimentary rock exposed in Pakistan, their depositional environment, sea level changes, and their tectonic relationship. So in this presentation, we will be focused on the sedimentary package of Pakistan, their environmental depositional changes on the sea level change or due to the tectonic relationship. So let's start. So first is the tectonics of the northern West Pakistan, a major fault in their role in exposing the Pakistan sedimentary strata. So firstly, we focus the tectonics of the northwestern Indian plate. Pakistan is mostly thrust faulted and which facilitate the strike strip or transform fault because it's the northwestern margin of the Indian plate where the convergence are very strong. So there is no normal fault, only we see the strike strip or thrust fault. This is the major fault of their abbreviation, and you see this is the various thrust fault like MFT, main frontal thrust fault. And this is the MBT, main boundary thrust fault, main central. KIA, Khoistan Island arc. This is the major transform fault, Chaman fault, which is the left lateral. So what is the tectonic evolution of Pakistan northwest Indian plate? So Pakistan on Jurassic time they are present in the southern southern pole, near to southern pole, but at Cretaceous to Jurassic they are cut from the Gondwana and start move toward the northward direction. At Paleocene they are present at the equator, so mostly coal layer or coal deposit form of the in the Paleocene rocks. And Eocene, you say it will be converted to the Indian plate and start the Himalayas Siwalics rock, which is the fluvial deposits. So now the current situation of the Pakistan is like this. You see there is the convergence with Eurasian and also with Somalia or Arabian or Australian plate. So this is the Indian plate and Pakistan is the northwestern region, but it's still going on the convergence subducted northward toward the Eurasian plate. So it Archean to Proterozoic age, this is the tectonics of the Indian plate. But oldest rock in Pakistan like Shield, Nagaparkar and Chaghi are the remnant of the Archean to Proterozoic rock. Uh, Paleozoic rocks in Pakistan are also present. In Paleozoic, the Indian plate are the southern continent and they start the Gondwana formation. So this is the Indian, this is the Pakistan. So they start convergence and divergence to form the Gondwana plate. But in Mesozoic, they start splitting from the Gondwana, uh, forming the Paleotithys, New Tethys, KIA, start like move Indian plate. In the north they are Paleotithys in which the intra-oceanic subduction are occur, which forming the KIA Khoistan Island arc, and this KIA splits the New Tethys and Paleotithys ocean. Firstly close the Paleotithys and then New Tethys ocean closes, and further Indian plate movement results the Indian Ocean opening, and the Paleocene to Eocene firstly collide with the northern and then will collide with the western margin of the Indian plate. So this is the zircon data which indicates they firstly collide with the northern and then with the western region. The extensive Deccan Trap basaltic eruption which occurs 65 to 60 million years is also manifested or give the fraction to the Indian plate which move very fast towards the northward direction and finally collide with the Indian plate at the northward direction, in which form the Khoistan Ladakh arc and this different arc and starting the Himalaya origin. But you can still see the western margin is opening and still deposition of the sedimentary package of like carbonates, but in the north they are starting the fluvial deposits. At 55 to 50 million year, the Chaman transform fault closed the Tethys Ocean, and now the complete Tethys Ocean are closed and start fluvial deposit. But now it's still subduction are occur 4 to 5 centimeter per year at northward direction. Indian plates subduct beneath the Eurasian because Indian plates are the mostly sedimentary to volcanic package which are less dense than the Eurasian hard rock, so they are subduct beneath the Eurasian plate. So classification and geological overview of the sedimentary basin in Pakistan, their tectonic evolution and depositional setting. So in Pakistan we have different basin like Indus Basin, in Indus Basin upper lower Indus Basin, sedimentary basin and Basin Basin. In upper basin Kohar Potwar Plateau and Suleiman Keter Basin. So in these basins you see the sedimentary package which is exposed from Precambrian to recent, but in the northern direction you see the igneous metamorphic rock exposed. This is the different basins, Indus Basin, Balochistan Basin, Kohar, Keter and Basin Basin. So this is the different rocks which are present in these basins, sedimentary basin. Indus basin are divided into upper and lower basin, but mostly people also say central basin also present in upper Kohat Putwar, and central is Suleiman Fold basin, and the southern is the Kirtar basin are present. So the comprehensive overview of stratigraphy across the sedimentary basin of Pakistan is these are the various rocks of the sedimentary from Precambrian to Cenozoic in Pakistan. So in the upper Indus Basin starting from Precambrian to recent, but in the lower or southern basin start from the Mesozoic, which the oldest rock is Volgai Formation Triassic age day to the recent age. So they have different environment, different rocks like carbonates, evaporites, clastics, having showed different tectonics. Too much extensive research gap, too much extensive research occur in these kind in respect of oil industry, in respect of paleoclimate, in respect of tectonism. So these are the sedimentary overall package in Pakistan. The tectonic evolution deposition sedimentary formation in Pakistan, a geological perspective. So these are the different rocks in which this is the lithological diagram in which Tirthan have limestone, and for example the Ranikot is also limestone, but the Gazij has shale. So this is the lower Indus Basin stratigraphic complete stratigraphic log. This is the upper Indus Basin stratigraphic log. This is the depositional model in Cambrian time in Pakistan. The western margin is exposed while the eastern are down, so mostly deposition occur in the eastern margin, while in Permian to Paleocene most of the rocks are deposited in towards the western of Pakistan, while eastern are exposed. So these are the groups: Baroch, Musagir, Saluj, Nilawahan, Jehlangur. So these are the groups in which the Keuda Khosa Jutana, so these are the Bagawala, their formation are present in these groups. So in 55 to 55 million years, the northern side is collided, while the southern side are still deposition continues like Namasakesa, Chorgali, Eocene rocks, Gazij, Lake, Sui limestone in the lower Indus Basin, and this is the upper Indus Basin. Eocene rock are still forming. At the 56 to 49 is still the northern, and the west to east direction is closed, but still the lower Indus Basin start deposition of the carbonate or ocean, Tethys Ocean deposition like Kirtanari, Gaj formation. So in the last, the Precambrian rock exposed in Pakistan, their deposition and sea level dynamics. So in Pakistan, oldest rock are present Precambrian rock. these are trench formation in which marl, gypsum, shale, dolomite are present. So mostly the Precambrian salt trench formation are present in the decollement zone of the MFT fault, but this is the type locality of the salt trench formation. They are exposed to 830 meter, but in subsurface 2000 meter. uh, Whenever you see the cross section, so they give the decollement to the sedimentary package of the Paleozoic to Mesozoic sedimentary package. The evaporite give the decollement to the sedimentary package, which is overlie above it. In these chaorites are present in salt trench formation. So in these chaorites, this gives the information about the salt trench formation, that 720 million year. They have some dating occur, and also they are alkaline rich magma. So what it shows, alkaline rich magma shows that it incompatible element like potassium, sodium, or alkali metal, which mean that low partial mating occur. So it means that little bit drifting occur. So due to the rifting, these marl are a deposit, which is the mixture of calcium carbonate and clay mineral. So calcium carbonate is formed due to the rifting and lagoonal kind of setting, while these marl are of the clay or of the clastic sediments is occur by the river or something like Aeolian sediments, and they are moved and deposit in the this lagoonal kind of setting. We also see the black shell in the lagoon salt trench formation. This black shell is because of this the high saline environment, which organisms are die due to high salinity and oxygen low environments, due to which the organic black shell are deposited. So basically the oil shale and salt trench formation is because of the deep of the lagoonal environment. So upper contact with Kevlar sandstone, lower contact with the schistose rock of the Indian plate. It also correlated to the Hormuz salt in Iran and Oman, but in Pakistan they have a good hydrocarbon source rock for Cambrian reservoir. You can see this. This is the three members in salt trench formation: Binyawala, Bandarkas, Sahiwal, Mal member. In Sahiwal, mostly Mal, which is calcium carbonate, and clay and clastic material. Bandarkas, they have gypsum, and the last is the very older is the Binyawala salt member. So this is the depositional model of the salt trench formation. In salt trench formation, we also see the evaporitic formation model, like we see the calcite, gypsum, halite, potassium. Like for example, this is the field photos of salt trench formation. You see the gypsum, rock salt, red marl. You can see inside the mine of the salt trench formation, they have very beautiful rock formation in the inside the mine of the evaporate salt. This is the second largest mine, which is known as Kevlar mine. You can see black shell are present in this part. This is the pyroxene needle. This is in this part we have gypsum, marl. So the research gap in present in salt trench formation is the unicellular to multicellular evolution. If you study the very detailed biomarker and you can record the evolution, so it is a big mystery of the evolution from unicellular to multicellular evolution, and this evaporate to the Cambrian transition. So no biomarker study in Pakistan. So this is the very significant gap of understanding its paleo environmental in evolution history. The role of evaporite is this structural geology gap, the detachment and the rheology thickness. This is the major, what is the tectonic stresses on deformation. So this is the gap in the structural geology. These two are the sedimentary and paleoclimatic gap, and this is the structural geology gap, which is present in salt trench formation and future student if they are work, so it will be good for him. So my next presentation will be the Cambrian strata of Pakistan. So I started my presentation on that, uh, and then we will be cover the Permian, then we will be cover the Mesozoic and Cretaceous, and then Paleocene, and then Eocene. So these are the different rocks which are present in Pakistan. So our next presentation is the Cameron Rock of Pakistan depositional model and sea level change. So thank you for your patience to understand this. Thank you.